All right, so the first thing we need to do is you need to download these programs, and these are all Windows-based. So unfortunately, if you have a Mac, you're going to have to use Parallels or Boot Camp or something like that, because all this stuff is Windows-based. So the first program you should download is this one here, PIPP. These are all free, and this program basically accomplishes sort of two important things. For those of you using like a DSLR or a large chip camera, this one will basically help you cut down the file to basically just the region of interest that you require. And what it also does nicely is it does kind of the first cut at processing your entire video. So you can select like how much of the video you actually want. So the program itself, if you look at it, here's what it looks like. This is the little program window, and it's pretty simple to use. You basically just select the file that you want. So in this case, let's say I add a source file, and you go to where you have your stuff. Here's my Mars data. So let's go to, let's say, here's the red channel, and here's my original file. My original file is an AVI, and it's 2.6 gigs in size. That was a file I showed you before of the planet moving around. So you could see that the planet was fuzzy, and it was full of atmospheric distortion, and it was moving around the frame, right? So one of the things you want to do is have the pre-processed image as centered as you possibly can, and hopefully the best frame. So I'm going to select this, and here's the actual first frame, just to show you kind of what it looks like, right? And one of the things I do with my camera in this particular, for this particular Mars capture, I used an ASI 178 mono, which basically is like a 3 megabyte pixel, like 3000 by 2000, something like that, sort of pixel array. And what I do is I shoot at what I call a region of interest, what they call a region of interest. So I'm only actually capturing an 800 by 600 window, because obviously planets are small. So when you're shooting a planet, you really don't care about the rest of the area. You just want the actual target, right? So if you think about your sensor is wasting a lot of space capturing all this black area when all you really want is the core. So the key to do this, of course, is that you need to have, you're going to be shooting at high magnification. So you want to basically have the image as centered as possibly over the period of recording, which does mean you need a decent tracking mount of some sort, because you're shooting at such high magnification that you're not going to be able to manually track it. So the only way you could really do it manually is if you were shooting over a very short period of time, maybe at just a couple of seconds, which again means that you have to shoot at a very high frame rate, which again means that you want to use as little of the chip as possible, because the smaller the area of the chip, the smaller the amount of data, the faster the chip can throughput. So in this particular case, we're using an 800 by 600 array area, and you can see that 800 by 600, Mars is still pretty small, and this is the Mars opposition. So you can actually see here's the 800 by 600, and you can see that Mars is what, like, if we eyeball it here, about 100 pixels this way and about 100 pixels that way, maybe not even, like 75 pixels by 80 pixels, right? So I could have even have gotten a smaller window, right, and have faster throughput. So this particular video is probably shooting at about 90 frames per second, right? So as I explained before, you want to capture those brief moments of good seeing, so you want to have as fast a frame rate as possible. So if we do this, so I'll go back into here, right? So I'm going to select this one here. No, I did not use a Barlow. Yeah, I did not use a Barlow. So this is just through a Celestron C8. So it's 2,000 millimeter focal length. So there's not much to really worry about. PIPP's pretty easy to use. You select planetary. You can do all kinds of stuff with here. You can do rotations. You can do ISS captures. There's a lot of fun stuff you can do with this. But the bottom line is we're just going to focus on the planetary capture. You can see here that I'm using, you got a bunch of different features that you can do here. So I do object planetary. I do detection, which allows me to effectively center it in my screen. I'm doing mono, but if you're having a color camera, you would do color camera here. And it's pretty simple. You go to output options. I'm just going to save it as a .avi. I'm going to save it in the same subdirectory, pretty simple stuff. And then you go over here to do processing, and you say start processing, and it starts to do its thing. There it goes. And I don't know how fast your computer is, Stan, but okay. So while it's sort of churning around here, let's go do something else. So that's one program that you need. The other program that you should download is also free, is Oto Stackert. And so here's Oto Stackert. Here's the image. So Oto Stackert, you want to go into download, but here's the trick to it. You go into download, but you don't download here. You basically go down to where it says beta versions, because this file here, the 2.68 file, is from 2016, and the more recent ones are in the beta. So if you go into the beta here, you'll see March 31, 2007, it's 64-bit. And you want the 64-bit version because it's just much faster than the 32-bit older version. So this is the second program that you want. And then the third program that you want is Registax, which has been around since 2011, and it's still pretty good. So you go to this website, Registax 6, and you download Registax. Pretty self-explanatory. There's this one weird thing about Registax, that you have to download the main program, and then you download the release, which then updates the main program to the latest wavelets. That's the only thing you have to do here. So this one's pretty straightforward. Those are the three programs I'm going to show you today, and that's all you really need. So let's go back to where we were. Let's see where we are. Okay, we're at 15%. So as you can see, this is still pretty slow. But let me go into sort of. So that's exactly what I was going to show you. So let's go here and take a look. So if we go into the Mars data here, so this is my original program. Now let's go here and show you. So here's the original file, 2.67 gigabytes, and here's the original shooting of that. So again, this is shooting at 90 to 100 frames per second, and again, part of the reason we're using PIPP 6,000 frames that are shot here and compress. You can tell it how many. I just leave it at default, which is 1,200. So if I had shot 20,000 frames, it would pick the best 1,200. But again, that number you can change if you wish, right? But part of the thing that we're doing is picking the best frames, and then we're going to center it, because you can see that over the 1 minute session, it kind of wandered around, right? So you basically want to have it centered so that when you're stacking it, it's all stacked in the center, right?
You should have it like in the center regardless, or at least it's supposed to, especially like an uncorrected scope.
Yes, but remember, even if you have a really good tracking mount, the problem with Planetary is that you're shooting at really high focal length. So because you're shooting at really high focal length, it's going to wander. I mean, just literally by walking around the scope, you will make it wander around, right? So anything that you can use to help you do that, right? And like sometimes what I would have happen was I would have it sort of centered, and then I would get a breeze and it would like shift over to here, right? And then I would use my little hand pad, and it would go back, but then I'd overshoot and it would go off the side of the screen. I'd be like, ah, damn, and I'd have to like bring it back, right? So when you're in the middle of the capture, right, you don't want to necessarily lose all those frames. So by using PIPP, it'll basically select just the best ones and center them for you. All right, so let's go back out. Let's see if we're done on the stacking here. Okay, we're done. Yay! Okay, we're done. So now I'm going to go into which I shouldn't have closed. I'm going to go back into my thing and go here. And it was R, I believe. Yeah, here it is. So here's the file. So here, if you can see here, the original file was 2.66 gigabytes. The new file is 235. Now let's take a look at the new file. Now remember, so PIPP has graded the best frames. There you go. So these are the best frames. So now it's not moving around, and look at that. It's in the center, and we can see the polar region in all the frames, as opposed to the other one that you saw was all like messy and blobby, right? Again, there's not much here, right? You can see a little bit of what looks to be detail on the planet's surface here, but again, it's sort of not that impressive, right? I mean, in terms of what we got. All right, that's step one. 1,200. Yeah. So exactly. So if I go, I think did I close it? No, here it is. So let's take a look. So here's the resulting data output. So 5,690 frames. See this here? And it processed the best 1,200. Right? Yes. Yes. So you see this right here, quality options? Only keep the best frames 1,200. You see that? So you can just design that yourself. So if you take a really large file that has 20,000 frames and you only want the best 100, you would also do that here. You could also do that, okay? So that's our first step. So now we've gone from 2.6 to the best 235, right? So what's the next thing we do?
Go ahead. This works on it.
Does that have any effect? Is it hard to see?
Yeah,
It's a little washed out.
It's okay. Yeah, text is washed out.
We can see the images, but the text seems
All right, well,
that's okay.
it could just be the resolution stamp. It could be the resolution on this thing. Just maybe not up to it.
Yeah, because it's different than what I have.
Yeah. All right, so next program we're going to use. So that was the first one, which is PIPP. The second program is Oto Stackert. So Oto Stackert is going to take those 1,200 frames, and it's actually going to do two things. One, it's going to grade those again, and then we're going to stack a certain proportion that we determine. So we just very simple to use, basically just open it up, go down to where our file is. This is the most recent one. So here's the file, right? 235 megabytes. Open it up. Okay, here's the planet. And you have to, with Oto Stackert, you have to do one thing. You have to click in a certain spot for it to sort of know that that's what you want to stack. So I'm just going to click on the polar point. That's it. So all you got to do is click there, and then you do planet. This doesn't really matter. I mean, I usually just put it at 3 for the quality estimator, and then you basically just do analyze. So here goes.
So you don't do the double stack?
You could, but I'm just trying to make it quick, right? So here we go. So this quality graph, you know what? Let me show you something before I do this. Let's do this. This is what the quality graph looks like of the PIP, right? I could have also opened up the original AVI. Here's the original one, the one that we didn't stack, right? And let's just analyze this one, just to give you an idea, just see how different it is. Now it's going to take a little longer. Remember, this one's 2.6 gigs. So you could use Oto Stackert without using PIPP. It could also do the same thing because it also grades, right? But I'm going to show you sort of on this output. You'll see why I like using PIPP first to give me sort of a more manageable data set. One, it's faster because you can see this is much slower, and two, you'll see on the quality graph here when it comes out, it's going to be much more variable, right? So so here you can see this quality graph, right? It's a little bit all over the place, right? And the only thing here is that one of the things we're going to have to do is estimate how much of this we want to capture. So as you can see down here at the lower end of the curve, so if this is the first 25%, this is the 50%, 75%, 100%. The last sort of 20% here is pretty bad. And there's certain, there'll be certain times when you capture stuff where this quality graph will be all the way down here, very low quality. And in a case when it's very low quality, using PIPP will give you a better representation without necessarily having to guess where the best stuff is going to be. So
what would be an optimum graph?
Well, the optimum graph, a better graph will be kind of what we did with PIPP right here, like this one here. So this graph.
They can't really see that secondary graph behind that.
Oh, you can't see it. All right. So yeah,
There actually is another graph behind that green line that you could.
Yeah.
You can see.
Yeah, you can see. I guess in the same. Yeah. So
EG kind of.
I'm sorry. Yeah, you can't. I didn't even realize that. Yeah, there's behind this screen here. There's another data set which doesn't show up here. But anyways, yeah. So with PIPP, it's a much tighter. If you look at the other one, you can see it's much tighter. So now we've analyzed. Again, this is the best 1,200 frames. And what I normally do is I'll basically say how much of this do I want to capture. Now, this green line shows me that I hit the 50th percent threshold at around 25, 30%. And that's usually what I'll do. I'll say, okay, well, I just want these frames from here to here, right? So I'm going to say 25%. I'm going to put in 25% here. It's also faster to do this. Sometimes you can drizzle. Now, drizzling will take longer, but what drizzling is doing is the computer is interpolating extra pixels for you. So it basically is trying to guess. Like for instance, when Mars is moving all over the place, right? It's going to see a pixel here, and it's going to see a pixel here, and it's going to see another pixel here. And when you don't drizzle, it's just going to focus on what it sees. When you drizzle it, then it's going to try to guess whether or not some of these other pixels are good pixels, and it'll resample. So it'll basically take an image that, say, if you think of it like, let's say 70 by 70 pixels, and if you drizzle it 3 times, it'll actually blow that image up to 210 by 210 pixels by trying to interpolate, where the best sort of extra pixels are. It does take a little longer. So in this case, I'm not going to drizzle it, but that's something that I would normally do that. Actually, you know what? Let's just see if not tax Stan's computer too much and try that again. So we'll do that, and I got to put my little dot on. I'm going to put on the polar region, and we'll stack that.
You don't pick alignment points?
You can get a little bit anal about it, but I usually just pick one. I mean, you can pick 3, 5. Yeah.
I noticed like on Jupiter, I had a really bad
Yeah.
one, and you put like 4 alignment points, and then you see 3 lines going that way and 1 line going this way.
Yeah.
Like, okay, well, obviously,
Yeah.
something horrible.
When I would do that on Jupiter if I had the Galilean moons and I wanted to align the Galilean moons, and they were like out here, I would pick them, right? So, but just to go back a second for who just came in here. So, the 3 programs we're talking about here are Registax, which is free to download, Oto Stackert. One point I made about Oto Stackert is when you download it, you have to go to the beta version, because the beta one is the one that's got the 64-bit, so just make a note of that. You want to do that. And then the first program I talked about is PIPP, which is also free. And PIPP helps you basically cut down your original file. So the thing that I had been sort of mentioning was, if we go back to my original data set, so my original data set was this 2.7 gigs of Mars, with Mars kind of moving around the frame. And you can see that some of these frames are pretty bad and others are a little better. Like in this one here, this one right here, you can't even see the polar cap, but yet in this frame right there, you see the polar cap, right? So the thing that PIPP does is it helps you grade the frames so that if you are shooting a lot of frames, and in this case, what I did was on PIPP is I basically got that original 5,000, and if you see that 5,600 frames, and we selected just the best 1,200, so that when we did that, we went from that moving blob that you saw to this instead, which is the best 1,200 frames. So 2 things here. One is that the frames are much better, so you can see the polar region, you can see some of the surface area, and it's not moving all over the screen. So that's the advantage of using PIPP. Then after we do that, we go ahead and stack it, which is what I just did. And then after we stack it, we are going to go into the last program, which is Registax, and we are going to pull in the stacked image. So stacked image, and as you remembered, I took the 1,200 frames and I said, give me just the best 25%, right? And here it is, and boom, there it is. There's Mars. So now you have this, okay? Registax can also be used for stacking, but it's a much slower program than Oto Stackert. And Oto Stackert has a few more bells and whistles for stacking than Registax. So why use Registax, which is a program from 2011? The only reason to really use it is because of this feature here that's called wavelets. And wavelets are really cool. They basically allow you to sort of enhance detail. there's one big pain in the butt about using wavelets, and that is that you can basically see that there's 6 wavelets. So think of wavelets as like layers. So like wavelet 1 is sort of the first layer. Wavelet 2 is the second layer. So like if you think about, when we look at an image like this, we always think, okay, this is a 2-dimensional image, and the camera has captured this 2-dimensionally, right? So it's the gray image, so 256, let's say, colors, scales of gray, and they're all the same. But in actuality, the actual data file has different layers beneath this. So it could be 256 on this layer and then 256 below that, and there's actually 6 layers. So what you can actually do is you can tweak each layer and try to tweak to sort of get some extra detail. The problem with doing this, as you can see here, I'm sort of futzing with it, is that it is really, really slow. So if I did that, okay, oh gee, does that look a little better? I can see a little better. But this is one of the worst things about astronomy sometimes, is that there's a huge amount of trial and error, right? And you could literally spend, believe me, I've done it, hours playing around with these things. And if your computer's slow, it could take forever. Fortunately, definitely remind me to give you guys this, because this is key, is take advantage of the fact that I've spent hours doing this. And so you can just take a few of my canned wavelengths. So what I've done is, when over 3 years ago, when I was a little bit more into like this planetary stuff, I would painstakingly do image processing for hours, and I would get like a eureka moment and say, oh my God, that looks great. And I would save that one wavelet, which is basically saving where each of these was at the right time. And I have these canned processes here. So now what I can do is I can just guess. I don't have to guess each one of these. I can actually just go into one of these and say, I wonder how Jupiter Mono 2 would look. And it'll adjust all of my wavelengths, as you can see. It'll do its little processing, and boom. And I can say, oh, it looks a little better, but maybe not that great. Let me try another one. So I can go down here again, and I can say, let's look at Mars 2. And it'll do the same thing.
Did you mean that it just doesn't plan?
Yeah, exactly. That's it. Exactly. And the key, again, is to play around with it. So you can see that some of these will give me better results than others. Right? And I'll do a few more here, just see what we got. That one's not so great. Hold on. See, that one's not so good, right? Some of these will be better than others. Again, it's a function of you're kind of trying to guess at which of the layers are cleaner than others. So you can see that one's a little fuzzy. And again, doing it this way is much faster than actually moving each of those settings yourself, which can take a very long time. So you can see these are not that great. Let's go to this one here. See if I can get a good one here.
If you wanted to do it,
That one's not bad, right?
Alfredo, if you wanted to do it manually, how do you decide how to
Complete guesswork.
each layer?
Complete guesswork. That's why it's such a. I mean, I think there is a science to it, in the sense that I used to know which each of these layers did. Like, but again, for Jupiter, you got the bands. It's a little bit cleaner because you can actually see some differentiation. With Saturn, you can see the Cassini division, right? But again, it is trial and error. So having these canned ones is easier. So now I'm going to say this one's not that bad, but let me try one more here before I go back to that one. Because I can also do a few more. Okay, that one's not so good. All right, so let's go back to this one for a second. Let's just try something. So this is one thing that you can do. So wavelengths, right? Now, the other thing you can do is you can actually go to the histogram. And here's the histogram. And you can basically pull the histogram out. Now you got this. Now you get to see something a little nicer, right? So now you can actually see. Here's the polar region. Here's the actual surface detail on Mars, right? And you can also go into the gamma slider, and let me move this over. And you can just grab this thing, and oops, sorry about that, and go around and move it around to sort of see. So once you've adjusted your wavelet, then you can play with these other functions here, and basically get a much cleaner image, right? And you can actually start to see some detail and start to get some benefit from all this processing. I mean, you know, all that together took us what, like 10 minutes maybe, right? So it's relatively quick and easy to do. And then, of course, you know, what what I would then do is I would basically get my original data set here, right? And I would get sort of each of my different sort of color. This a mono camera, so different colors. You can see here, like this was my green channel, right? Not as much detail in green. My red channel, which is the one that's got more detail. This is a luminance channel, right? And you put them all together, and then you basically can play around with the colors and try to get some, different detail colors or whatever, and you can sort of put something together. That's kind of like the goal. And again, Mars obviously has had a lot of issues with seeing conditions and with, of course, dust storm. So you can see some of these are a little better than others. This is 2000. Yeah.
How high was Mars?
Oh, it's really low. It's like 15, 14 degrees. Exactly right. Exactly right. So now we got that. So now let's go ahead and use your data. Okay. Let's use your data and see what we can do.
Let's see if it actually works.
All right. Yes.
No, there's
Just pull out mine.
yeah.
I'm sorry. It means that Mars is going to be smaller, right? Mars at opposition this year, right, is reached a peak. All right, so
what do you mix the colors in? Do you do it in just the?
I do it in PixInsight. Yeah, but I mean, I can probably do it in Photoshop or GIMP or something like that as well. The nice thing about PIPP again is the fact that because it lines it up for you, so then you don't have to worry about like moving things around manually to try to line them up. That's one of the advantages, right?
The images that you're showing us, is that basically the same 800 by 600?
They're all 800 by 600. But here, let me show you a couple other ones here. Let's just see. So let me look at one of my luminance ones here. This one's 3.7. Let's try that one. Let me see if I have a bigger one than that. No, that one doesn't have anything. All right, so let's go back to that one. So here's the luminance channel. This one's a 3.7 gigabyte file. So here's luminance. Now this one here you can see really bad here, right? I mean, look at that, right? And then look, it goes off the screen, comes back up on the screen, goes off the screen, comes back up on the screen, goes off the screen, right? So this is normally what would happen to it. I showed you the good one first, right? This is normally what happens, right? You're like, here it is on the screen. It's like, oh damn, I bumped into the scope. Okay, I got to walk over there. Oh, there's a big mosquito. It's like flying around me. Right? So here's all over the place, right? So as you can see, that one's, so if we go in and we sort of say, please help us with this one. So I'm going to go into PIPP, and I'm going to go source file and remove this one, and let's go ahead and put that one in. It's the right one. Nope, it's not that one. It's the other one. Yeah, so here's the file. Okay, and I'm going to go over here and tell it to do processing. Now this one's 7,943 frames, right? Now let's do this. Let's see, quality options, output options. Okay, I'm going to tell it, I just want to see the best 300 frames, right? I don't want the 1200. Let's just do the best 300. And tell it, go ahead and start processing. Now, that's going to take a while. While that's happening, let's do this. Let's go into Registax. And let's go ahead and open in Registax. The program, the one that we did last time.
When you're getting these, do you aim for like 80% histogram or?
I only do that in terms of the capture. No, I probably should, but I just eyeball it, right? I mean, the key is, you're setting the gain or the exposure setting on your camera, right? And you're going to get to a point where the exposure setting is going to be too exposed, and the planet would look like a white blob, right? So then you have two options. You can change your ISO. You're shooting such a bright object that you're probably going to be shooting at low ISO anyways, right? So the key thing is to get a good balance on your exposure setting, because you want as many frames per second. So ideally, you want to have sort of a relatively high ISO and as high a frame rate as your camera can go, right? And still get a decent image. So what I normally would do is I'll sort of optimize those two things and say, okay, well, I want something that's not too bright, right? I use it really bright to focus it, right? Because usually when it's bright, you can focus it either with a mask or you can just eyeball it and sort of where the focus is. And then I will back off on the exposure time to try to get less sort of a faster and faster exposure time so I can boost my frame rate. And I'm trying to get as many frames as I possibly can, especially for you guys if you're not using a good tracking mount. The biggest obstacle you're going to have is shooting at high focal length, is that you're going to have the thing moving all over the place. So you want to be able to capture as many of those frames as possible. So in this PIPP one, right, we got 7,953 frames, and you can see there's probably thousands of frames where Mars is not even on the thing, right? So so by the way, oh, okay, we're at 99%. All right, let's just see what happens now. Okay, that's pretty fast because we told it we only want the best 300, right? So there it is. It's powering through that much faster. Let's see here. Finishes. We talked about that. I think the problem with stills, again, you're in terms of traditional astrophotography, right? But in terms of planetary, this is now our best. Here's our best 300 frames. So again, we got only the ones that are. It centered them all for us. It put them all in the center. This looks overexposed to me, so it's going to be interesting to see how we process this. All right. So the problem with doing individual frames. Let's say you set your. Let's say I'm capturing at, let's say, 3 milliseconds per frame or 5 milliseconds per frame, and let's just say each frame is a megabyte, right? Or let's say it's 500K kilobytes, right? So then you're going to be limited by the input out of your data storage device. So if you have a really fast, card that can throughput like 10 or 12 megabits per second, you might be okay up to a certain amount. But if your card or if your data storage device is going to have a bottleneck and you don't have a buffer on your camera, that's a big buffer. If you're saving 6-7 gigabytes of data, chances are you're going to go over your buffer. Then you won't save it. So if you do a video, it's basically not writing every frame, but it's writing chunks of frames. So the read-write on your card is not a roadblock. That's the main reason to do video. That's the main reason. All right. So now we got that. Let's take a look and see what we got in Oto Stackert. So let's open up that and see what it looks like. Was it this one that I used? Let me see here. Nope, not that one. I always do the wrong one. It was this one. And there it is. And there's my file. Pull it up. Okay. Now you can see it's overexposed. Let's go ahead and see what that analyzes. Now here you can see that the quality graph is not as good as the other one, right? So I'm going to tell it to just stack. I'm just going to tell it to stack the best 20%. And I'm going to tell it to drizzle 3 times, just because it's not a lot of frames. It shouldn't take that long. And there it goes. There it is, done. And now we're going to go into Registax. And let's pull up that file. Is this it? Yeah. Now, you see how much bigger it is? Do you remember how big the other one was that we pulled in? It was much smaller than this, right? And this is because we drizzled it 3 times, right? So let me just, so again, same basic process that I did before. I'm just going to go through my little canned things here and try to find something that gives me a little detail. It basically does 2 things. One, it'll make your, so for planets, it'll make your final image larger. Do you remember when we did the PIPP here, right? So here's my original one undrizzled, right? Look at the size difference between these two, right? So you can see this is the actual 800 by 600 array that I captured, right? So my planetary camera that I used has like 3,000 by 2,000 frame size, but I'm only using an 800 by 600 array because I just want much higher frame rate, and I'm just focused on that one little area. And you could see I could even have gone smaller than that. If I had gone to 320 by 260 or whatever, I probably could have got 150 frames per second, right? But again, my Mars is only about 75 pixels per side. If you look at it here, right? You can see here's the, I don't know if you can read that, but here's the actual number of pixels, right? So from here to here is about 70, well, maybe 100 pixels. So this is 100 pixels, right? But now look at it on this one. Again, these should be sort of commensurate, but if I put in, you can see it's almost like 400 by 350 or something like that, right? So the first thing that drizzle does is it expands your object of interest. And this is true not just for planets, but for DSOs. So if you had a camera that produced, let's say, 5,000 by 5,000 frame, and you drizzled it 3 times, you'd get 15,000 by 15,000, right? So much larger. And then the other thing it does for the original image that you saw was bouncing all over the place. Drizzling is trying to sort of interpolate where all those pixels are. So there's a chance that when you got a bad move, when Mars moved up here and it was pixelating up here, there could have been a couple of moments when there was actually good seeing up there and the polar region was well defined. Drizzling would capture that, whereas your original non-drizzled image would not have captured that because it would have just cut those frames out because it was outside of the central region. So those are the 2 main reasons to do drizzling. Again, it's really sort of a function of if you have good focus, then drizzling is a good idea. If your focus is off, then it can be a little bit sort of problematic because then it'll take a lot of bad data and sort of incorporate it. So here is our image. I'm just going through my little canned settings to see if I can get anything out of it. And this one looked overexposed to me, so there might not be, you might not be able to save it. We'll see what we get. If we get, again, it takes, as you can see, it takes a lot longer to do each one, just because it's of the 3 times size image. You can go here. Let's go to the histogram. You can see the histogram shifted way over. Let's bring it over. See if that helps. There you go. A little better. You can see but you can see that. Oh, yeah, I killed it. All right, let's go back. All right, and then let's go back over here and try to get another one of these. But what's impressive is you got that ball that was going all over the place that looked really overexposed to a centered ball that still looked overexposed to actually something that you can start to basically get some detail, right? Because the thing about planetary imaging is that you're going to want to take as many videos as you can, right? And the more data, the better. So I shot all of this, about 20 gigabytes worth of data files, over basically a 40-minute period when Mars is in between two tall trees and the clouds are not coming in and it didn't start to rain, right? So you can do this, relatively quickly. It doesn't take a huge amount of time in actually capturing the data, but it does take a lot more time to sort of process it. And this one is not coming out that good. But let me get another one. This one here, I think the data is probably not as good.
When it's way overexposed like that, it isn't trying to interpolate what it's saying.
Exactly right. So exactly. Well, it's actually not bad because you can see a little bit of a little bit of detail there, right? And again, it basically, like I said, the different layers. So there could be some layers that are way overexposed, and depending on how these layers are adjusted, it could basically tone trial and error. It could tone down some of those really overexposed layers and then accentuate those layers that are not as overexposed.
I
So,
thought of another reason sometimes still images might not work. Is that Dan?
ooh, this one's pretty bad.
If still images take a lot longer to acquire, just in terms of, like, it could take an hour. If you're shooting something like Jupiter, I think Jupiter, if you shoot more than about 5 minutes, the rotation is so fast that the image starts to blur as you start to combine all stack all the images like that. I mean, Mars is probably less.
25-hour day, 24 days.
Yeah, less than right.
Yeah.
But then you could get a few thousand video frames in a fraction of the time, and still image.
So here's just one last one I'll show you. So here's one where I didn't drizzle it. So you can see, again, it's much smaller than the other one. It's a pretty big difference, right? This one versus the 3 times drizzled one, right, in terms of detail. And this is without any wavelets applied. So it's actually not that, it looks a little bit like a pear here, but it's not that bad. And again, you know, we can then we can go through that process of sort of guessing sort of which of these to use. Again, yeah. I mean, if you really wanted to be sort of a perfectionist about it, yeah, you could. But I mean, it all comes down to sort of your data quality. If you know, this was literally 40 minutes in between the trees, right? So, and Mars is so low in altitude now that you're going to get bad data anyways because of the diffraction. So you're kind of battling a lot of negative elements anyways. But if this was Jupiter or Saturn at a really high altitude, then you could be a lot more sort of discerning on the data and try to get more detail. I think that's good, right? I mean, yeah. Right. So. Thank you.